Hello, everyone. Welcome to episode 281 of the J Situation Podcast. I'm recording this on October 28th, 2025. How are all you folks doing on this wonderful fall day? Man, it's all good on this end. I love this time of year. We're on the precipice of Halloween. Spooky. Yeah, you're going to get some spooky stuff today. I tell you what, get your candy corn ready. Man, be sure to check your kids' candy for hazards, like circus peanuts. You know, those are gross. You got to stick with the candy corn. We're going to take a short detour from our regularly scheduled technical report overview, reviewing last week's Otter Creek Labs Infinity ACAPE report. Don't worry, that'll come next episode. We had to take a quick detour because today we are launching a new section of the Silencer Sound Standard. This will be Section 8, Advanced Silencer Research. And along with that, we are launching the first subsection, 8.1. It contains something that has never been done before in the history of suppressed small arms, to our knowledge. This is spatial silencer hazard maps that tell you the suppression rating everywhere. And I do mean everywhere. As a special treat, we can create these silencer hazard maps for you in the free field, or near reflecting surfaces, and even inside buildings. Yeah, we can now map your shooting experience in your real shooting environments. That has always been the goal. And so how are we able to do this, you may ask yourself. We have developed a new capability here at PEW-Science. It is called the PEW-SOFT HD Blast Hazard Prediction Tool and Hazard Mapper. We've been busy behind the scenes, some of you can tell. So stay with us this episode, and I'll tell you all about it. I am so excited. I wanted to tell you about this every day, and I couldn't say anything to you. And now I get to, so yay. The report published with this episode is really cool. And it's 100% public to everyone in the world. Yeah, that's right, 100% free. It's our contribution to the world. Super cool. Okay. So let's get on with the show. If you've been here before, welcome back. Glad to have you. You're in for a treat today. If you're new to this, oh man, did you jump into the deep end with this episode? I'm glad to have you. I'm going to tell you right now, I'm not going to read ads for this podcast. I'm going to tell you about our sponsors, but I'm not going to read ads. Okay, there are we just don't have time today for ads. Okay, we're not doing that. There are going to be timestamps in the episode description. For you to skip wherever you would like and to go back and reference stuff. And there's going to be a lot of timestamps because I have a lot to talk to you about, okay? A lot to say. Okay, so real quick, who makes this podcast possible up front? The companies, Legion Athletics, Silencer Shop, Capital Armory, Top Gun Range, and PEW-Science members, PEW-Science clients, and all you podcast listeners that spread the word. My family, my staff, my team. Thank you. Okay. So let's go ahead and I'm going to tell you we're going to have two topics. The first topic is going to be we're launching Section 8. I'm going to tell you this section is awesome, and I'm glad to start it for you. Second topic, we're going to talk about Section 8.1, and I'm going to talk about the first article in there about the hazard maps. Okay, so let's start topic 1 at a time of 3 minutes. I'm sorry, 4 minutes and 2 seconds. 4 is a better number anyway. 4 is actually, 4 is my favorite number. It's a good number. It's a perfect square, single digit. So topic 1, today we're launching Section 8 of the Silencer Sound Standard. That's Silencer Sound Standard .8, Advanced Silencer Research. Outside of public view, PEW-Science performs a significant amount of testing and engineering analysis on a variety of systems. You never see it, most of which is never published. None of you would know, because how could you know? A lot of you don't even know who we're doing it for. So I want to say right now, that's fine, but not everything has to be secret all the time. And Section 8 is going to give us the opportunity and the place to show you things that we can show you that have been cleared for public release. And so that's the whole point of Section 8, okay? And I'm going to tell you, sometimes I wish there was infinite time. I really do. I mean, likely there is actually infinite time. Likely, maybe. There's a couple theories on that. But not in this universe, certainly, and definitely not for us as individuals. Okay, time is finite for all of us. Time waits for no man or woman. And in the time we have, I think it's pretty neat to do things that hopefully make a difference. This new section of the standard is a place where we can show you things that don't quite fit in the other sections and that are a little more out of left field. Section 8 is a little crazy, but maybe just the right amount of crazy. You need a little bit of crazy to do this, right? I feel like you have to take a little bit of risk if you want to really push things forward, so here we are, okay? Now, unlike Section 6, both Section 7 and Section 8 have major subsection headings, right? So, for example, Section 7 is rankings, and Section 7.1 is suppression rating rankings, and there will be other rankings subsection added to Section 7 later, okay? That's not what this is. Section 8 is a lot like Section 7 in organizational structure, but that's all. The major subsections will include categories of research that meet the requirements of Section 8, and they have to be different enough from each other to earn their own subsection. Here are our requirements for Section 8 of the standard. First, the subject area has to be publicly releasable. We can't do things for this is a Pew Science Skunk Works, so we have to obey the rules of our proprietary stuff and, of course, our client stuff. Okay, we can't release anything into Section 8, of course, unless it's cleared for public release. So that's the first step. Okay, that's what we're doing right now. Second requirement: the subject area for consideration in this part of the standard, it has to provide meaningful contribution to the suppressed small arms state of practice, and either has to do that directly to consumers and end users, or to weapon developers, or both. Understand? If it doesn't have that applicability, it's not getting in there. Okay. Finally, the third and final requirement for inclusion in Section 8 is that the subject area needs to be novel enough such that new ideas get fostered and grown like little seeds. So we push the research forward from global user and market inertia. Okay, so stagnation is where death occurs. Okay, we're more interested in thriving. We don't want to stay the same and stagnate. We want to grow and advance, and so that's the point of this. Okay, so that's the short intro to the new section. It's pretty simple, I think, on its face, but also very important. So let's talk about the first subsection to be included in Section 8, which is Section 8.1, Silencer Hazard Maps. In Topic 2, at a time of 8 minutes and 22 seconds. Oh, very good. Very good. Topic 2, yeah. The first subsection in Section 8, which will be live today with this episode. Very excited. And the first report in Section 8 is, you guessed it, Report 8.1.1, because we're in subsection 8.1. First report is 8.1.1. Sorry for the numbers, but it's the way it has to work. There's no way around that. The first article or first report, it's public. Everyone can see it in the whole world. 8.1.1 is what? It is introducing PEW-SOFT HD hazard maps. Silencer hazard maps, to be exact. The suppression rating has made you, yes, you listening, has made you more powerful, hasn't it? Now you're going to become even more powerful. This is important. And you're going to be able to do that, you're going to be able to do that by navigating personnel hazards from the silencers you know and love in both the free field and near reflecting surfaces, and you're going to be able to do that everywhere. That's right, everywhere. So I'm going to walk you through the report in today's talk, actually. And you know what? You can actually follow on home if you want, because I'm going to try to publish this episode at the same time the report goes live. So no one's going to see this early. And no one has seen it early, by the way. No one in the firearms industry. They don't need to. That's right. We do our work differently. So there's an outline, and I'm going to go through everything. We're going to introduction, and then we're going to go through six sections of the report. We're going to start with the introduction, and then the 6 sections we're going to talk about. What are we going to talk about? Talking about dimensional variations. We're going to talk about free field data and why you should care about it. We're going to talk about the PEW-SOFT HD hazard mapper and what it is. I'm going to give you a Mark 18 case study comparing the Surefire 556 RC2, the 556 RC3, and the HuxWorks Flow 556K using the tool in the free field. Then we're going to talk about moving outside the free field. We're going to take 2 of those silencers and we're going to put them near reflecting surfaces and see what happens to show you the real deal. And then finally, we're going to wrap it all up, and I'm going to thank people who made this possible because it's important to do that. All right. So in the introduction here, just as a quick introduction to 8.1, these hazard maps, I want to say for the record, and you're just going to have to be patient with me today, there's going to be timestamps. So if you want to skip this, you can. This might be one of the craziest things we've ever done. I know it's one of the craziest things I've ever done. And I do believe this is one of the craziest things that anyone's ever done in the blast physics community or weapons effects community, and most certainly 100% without a doubt in the silencer industry. Like that I am sure. To our knowledge, no one's ever done this publicly in this way. Like I know because I would have just done it what they did, and they haven't. So, and I know if someone has done it, even if they haven't done it like we have. So I say all this to say, 1, I'm proud of it. But 2, the reason I'm saying this is because it definitely meets the requirements for Section 8 of the standard if you're already keeping score, which you should be keeping score if you listen to the previous topic because you're part of this, okay? If you've been listening to this podcast since the beginning, or if you've been following this research since we launched the standard publicly in 2020, you already know the background of what we've been doing, why we've been doing it, right? In 2020, in Section 1 of the standard, I wrote the PEW-Science vision in 3 main bullet points. It's been on there for almost 6 years now. Okay, anyone could have read it. My personal goal, my personal mission was to build upon the current state of practice by, I'm going to read these 3 bullet points. They've been there, they're 6 years old. Use existing nomenclature and terminology where appropriate. Improve upon existing methodology where possible and practical. Introduce new methods and combine them with established and peer-reviewed science to improve the state of practice. Okay, that hasn't changed. So what did we do? We took the existing MIL standard 1474 Echo, as many of you know it. We took that standard, which we actually thought was pretty good. And if you're looking for some OGs that also think it's pretty good, go talk to Reed Knight. That's one. I mean, he was there when they made it. Okay, so what we decided, the original, that is. What we decided to do was use MIL standard 1474 Echo correctly, because I'm telling you right now, we hadn't seen anyone do it correctly. And I'm not throwing stones. I'm just telling you, we literally had never seen anyone do it correctly. So we were like, we should do this correctly and see what happens. And at its core, I mean, we did this. This is old. You should already know this. It's all on the website. Because at its core, that's really what the silencer sound standard is. All it is MIL standard 1474 Echo done correctly. The manufacturers and dealers and distributors, the people that sell you silencers, dude, I'm telling you right now, and real talk, I'm serious. I am serious, and I will say this to you in person too. All those people, all those parties, they can say whatever they want all day, every day, and twice on Sunday about what they think PEW-Science is, or what they think we do, or what we don't do, and if they like us and if they don't like us, and they can argue and scream and yell until the cows come home, dude. And that's just fine. That is just fine. Like, we don't care. Nothing those parties do or say changes the reality that PEW-Science used the very same test standard that none of them were using correctly, and then actually did it correctly, and then started presenting actual analysis of test data, and created and used the suppression rating to communicate real hazards to the people actually using the dang products. And we did this with your help. We changed the industry and the silencer world, and it's public record, and no one can take that away from us. No one can take that away from you ever. So write it down. If you think you need to write it down or remember that, do it. Because you're never going to put the genie back in the bottle. The consumers and the companies are so much more educated now when it comes to silencers. The plan freaking worked. You love it or hate it, the knowledge base has elevated. You have companies that are using the word impulse in their marketing that they don't even know what it means, and they're still using it. We influence the silencer companies. We're not influencers on YouTube. We influence the companies making the products. And how do we do that? Because everyone was hungry to learn how the dang things are working. They're cool. Who doesn't love silencers? Let's figure out how they work and make them better, guys. We're working together on this. All right, 1 second. So we're sitting here, minding our own business, doing the work to help the world, we think, and plus it's fun. We became acutely aware that there were still other opportunities for education. We thought, we're like, you know what? We can make this better, even better than we have. And we hadn't reached the potential limits of the data we're gathering. More utility. We have all this dang data, over years, and it's really great. Very high quality, collected with the highest professional and technical standards, obsessively. And frankly, man, it's literally and objectively the best raw silencer data that exists in the world. Like, yeah, it is, okay? To this day, 6 years running, nothing's competing with it. So why not take further advantage of what? We're just going to let it sit there? No, that's dumb. We're going to put we've put our money where our mouth is, and we want to show you just how good the data is again. And we gave you the suppression rating, and it's always free. It's free, dude. The suppression rating is free to every single person on the planet on our website. So why not give you something else for free, we think? Why not tell you what the suppression rating is at every point in space, right? You got muzzle and ear. You got the big number at the top of the page in these reports that you've seen for years that it was the composite, and sometimes they don't like that composite rating. And why? Why is the real reason? I mean, I'm going to be very honest with you today. What's the real reason people don't like that composite rating? Is it because they feel it's not granular enough and not fair to all the technical nuances of the silencers? No. I know some of you don't like the composite rating because of that, because that's why you shouldn't like it. I'm going to tell you why they really, the loudest people don't like it. It's because someone has to be in first place and someone has to be in last place. And you can't have two winners in a race. And that just bothers people who are selling you products. And that's okay, dude. That's okay. I'm not saying it's bad. I'm just saying that's why. And I got news for you, though. In the name of user education and consumer education, we're about to make this a lot more visible. So if you didn't like that number, okay. One big complaint, and I'm going to tell you, complaint that we've heard, and people are going to try to find something to complain about no matter what. My wife tells me, she says, you can be the biggest, juiciest peach in the whole wide world, and some people just don't like peaches. And that's fine. But one big complaint is that, PEW-Science data only works in the free field. No one shoots in the field. Well, that's not true. But they're technically correct that, yeah, to this day, until today, PEW-Science data is only valid in the free field. That's what makes it so controlled. Of course. We wanted it to be apples to apples for you. Why would we not test in the free field? That would be the worst thing to do for a standard. So, because, you couldn't extrapolate it anywhere, right? So when you say, it only works in the free field, and you say that maliciously, well, that's kind of short-sighted in intent, because it's contrary to any respectable and established research opinion in the blast effects community. Worldwide. So today, not only are we going to eliminate that argument from the earth and salt the earth, we're going to show you why we've been testing in the free field for the past 6 years. And so we're going to talk about dimensional variation that you already know about, but you need to hear. Topic B, topic 2B at a time, 20 minutes and 12 seconds. I got to pick this up. This is going too slow. Okay. You need to understand, if you haven't already, and by the way, you can follow on with the report if you want on the website right now. You need to understand, if you haven't already, that your suppressed weapon system performance can change, and it will change. Actually, it's inevitable. Really, you are going to change your silencer. You're going to change your silencer, your mount, your gun, your optic, your shooting position, your ammunition, your gear, your freaking water bottle, your plate carrier, your chest rig, your holster. I don't care, man. Nothing's certain on this earth except for death and taxes. So I want you to keep 2 variable sets in mind. And if you've been listening to this podcast for years, you know what I'm going to say. First, the spatial variable. Where are you? Where are the people around you? What is around you? Second thing, the temporal variable. Say it with me. You're gonna laugh. The dimension of time. That's right. We talk about this all the time. How often are you shooting? What's the blowdown duration of your gunshot? What's the flow rate and early time? How does the timing of the blast wave hit your face? What's the bolt speed? How fast is your powder burning in your barrel? How much dwell time do you have in your AR? You name it. It varies with time. These are dynamics. Okay? In the physical reality sense of the word, dynamics. Not like the fancy influencer sense of the word, dynamics. Like this companies, like they name themselves Dynamics, and there's like 6,000 of them. No. This is like time domain varying phenomena. If things didn't vary in time and space, literally nothing Pew Science does would matter, right? Wouldn't matter. This is what we specialize in, right? We specialize in weapon system blast dynamics. The silencer sound standard, it probably should have been called the suppressed weapon system blast testing standard. And in hindsight, I really like that name, but I don't think it would have gotten as much traffic. Too late now, I guess. Let's talk about the data we gathered the past 6 years and why we did it like with this, and why we're continuing to do it like this despite what the people who sell the silencers tell you. And I'm going to show you why. Time of 22 minutes and 55 seconds. All right. I'm tired of this, man. How many times I got to tell you? And a lot of you heard me say this again and again and again. And we at Pew Science, we're simply not from the firearms industry, guys. And that's okay. I think, they've been welcoming. It's a neat industry, and we got a lot of friends now in it. It's cool. But we work in weapons effects, but not in the way people who are selling the guns at the gun stores and the silencers at the silencer shop and things like that. That's not the type of weapons effects. We work in physics-based engineering fields, on the attack side and the threat side, on the protection side, on the hazard characterization and mitigation side, everything in between. We help people that are trying to destroy things and trying to protect things from not only weapons but other things too, everything in between for decades. And in our field and professional practice, what we know from decades, I'm giving you based on experience. I'm telling you from what we know based on experience, all the study, all the research, all the projects, free field blast overpressure data is what you gather when you want to use it for stuff later. I remember like it was yesterday. Someone, I think I posted about PEW-SOFT on social media like 6 years ago to show people what it was. And the biggest thing I was excited about was the quality of the data we were going to get and what we were going to do with it later. And instead of like asking me questions about that, I'm not talking about consumers, I'm talking about like from the silencer industry. Instead of talking about that with me, you know what happened? they thought it was a sound meter, and they used the word meter, and it's for 6 years. I lost my mind. I'll never forget that. Now, there's a small compromise when using mil standard 1474 echo when you use it correctly to get free field data. The compromise is that it's a technical compromise and a practical compromise. And that compromise is that there's a shooter, and there is in fact the ground. And so the blast loads are free field blast loads, but there's a ground reflection component due to the sources being located above the grade level. You see, because we're shooting above the ground, so that means the blast waves reflect off of the ground, and they come to you, to the sensors, to everywhere. So in the data, there are shooter reflection components and there are ground reflection components, and we've showed you those. Now, how does PEW-Science deal with those compromises? Because this is real life. This isn't a textbook. This is real life. How do we deal with that? The way we made the decision to deal with it was consistency and reality. We were okay with the ground and the shooter being in the system fingerprints because it's standardized per mil standard 1474 echo, and therefore the silencer sounds standard. And when you're shooting a gun, you are a real person shooting a gun. That's right. Did you know? Like, if you measure blast overpressure next to someone's head, that's real. If you move their head, it's not real anymore. Let me say that again. If you measure blast overpressure near someone's head and you move their head and you measure blast pressure again, that your second measurement, that's not what would be there if the head was there. Yes. You're not shooting a gun in outer space either. There's a ground. Yeah. Okay. You with me? So the data we've been giving you over the past 6 years has let you have a universal key to performance, right? Yeah. No matter what, the free field is a constant, and any performance metric presented to you by us is guaranteed to be comparable to any other performance metric because it's all in the free field. It's all constant. And the metric we calculate from our data is the suppression rating. It's the universal Rosetta Stone for hazard for you using a silencer system. What does it use? Pure, uncut, pristine data. Pure as the driven snow data. Cleanest, highest quality, purest data. Now, what happens when you shoot your silencer in your hallway to stop that intruder? It's a bit louder. Why? Well, blast load reflections. From where? Hallway walls, hallway floor, hallway ceiling. Not good. The incoming wave is adding to the reflected wave, and the cycle continues. And in a hallway, it can happen for a while. Those pesky spatial and temporal variations coming into play. You can't get away from the dynamics. You cannot get away from that. Spatial and temporal. You can't get away. And it's not just a hallway, guys. It's not just a hallway. What if you're outside near your barn or in a barn? Or what if you go to a shooting range with an awning? Or what if your range is indoors? Sure, you're wearing hearing protection. But what if you start to get headaches because the silencer you're using flows too fast? And, I don't know. They told me this ARCS was really advanced, and I put it on my Mark 18, but I'm seeing white hot flash in daylight. My head hurts inside when I go to the range. Maybe I'll change silencers. I wonder why my head... Get my lead levels checked. I don't know. I just don't feel good. Micro TBI can happen. We think it's time to help you understand the spatial nature of hazards more than we already have and still incorporate the temporal component. So we want to, we don't want to just show you spatial hazards and forget about time. That'd be weird. And the suppression rating actually tells you a lot already, which is really cool. And so there wasn't always the detailed ratings in the early days of the standard. We just showed you the composite. Boy, we figured out pretty quickly that was a mistake. People need to know more detail, which is important. And the detailed ratings Oh, I'm sorry. Excuse me. The detailed ratings at the muzzle and ear give you so much information, but even so, we've realized some folks don't visualize things as easily as others, and of course, as we just spoke about, environments can change. So, maybe it's time to move in a direction where you see more spatial things, and maybe you just see the muzzle and ear visually, and maybe it'll help you. We're not sure, but what we know is that this is the motivation for moving to this next step in the research. Okay, we're going to take the spatial and temporal variation, including reflecting surfaces, and we're going to show you what happens visually. Okay, you actually won't even have to be able to read. Actually, to use this, it's not that advanced. The suppression rating's color-coded for a reason. Super easy. Now you're going to get color-coded maps too. And the best part about all this, all we need to make this happen for you is all the data we already have. It's that pure, uncut, pristine, free field blast overpressure data from PEW-SOFT. Now we're going to introduce PEW-SOFT HD, which is the next frontier, at a time of 31 minutes and 19 seconds. One moment. All right, how are we doing on time? Half an hour. Maybe we can get through this. Okay, so we're gonna talk about the PEW-SOFT HD Hazard Mapper. This is a tool. Okay, now I'm gonna say something right now before we go through this. It's all in the article, but I'm gonna say something right now, and you may laugh at me, which is fine. You may be shocked or surprised, which is also okay. I want to assure you I'm being serious. I know it sounds stupid, but I'm being serious. All models are wrong. Some models are less wrong than others. And some are definitely useful. They definitely are. I promise. I kind of, it's me and my colleagues, and I think almost every single mentor I've had over the years, we all live and die by this quote. I put it in the article. I thought it was, I've always wanted to write that down somewhere publicly. This is my opportunity. The reason we live and die by this quote is because we work in the field of applied research, and we solve problems for people based on experimentation and analysis. And without testing, you're not anchored to reality. So it's like you can really get off in the weeds. And we always tell the modelers, are you sure about that? You know what I mean? And it's a fair question. It's important to understand the limitations of analytical models. And the question becomes, how good of an answer is good enough for what you're doing? And then throughout my career, I've become better at answering that question. Personally, it's taken me a long time. I think being able to answer that question appropriately in different situations is something you learn over a lot of years of practice, and it's not easy. It's not an easy question to answer. Most certainly, it's very difficult actually, but once you get good at it, boy, it'll steer you well. And how good is good enough? And it's difficult for us perfectionists, right? You want to be perfect. Sometimes perfect is the enemy of good enough. I think that's how that saying goes. So with that introduction and disclaimer, let me introduce the tool. This is the PEW-SOFT HD Blast Hazard Prediction Tool and Hazard Mapper. So the report has the full rundown. Bottom line, let's see, I have the report open right now, and this is going to be section, what is this? 8.1.1.3. We got to do something about those numbers. I got to figure that out. The report has a full rundown. One moment. Bottom line, this is an engineering level semi-empirical computational analysis code that takes high fidelity free field test data and creates high fidelity blast load field predictions at arbitrary points in space. If you feed PEW-SOFT HD test data from any of the hundreds of tests on our website, it will predict what the blast load history is wherever you ask it to. If we want to know what the blast waveform looks like over by your your buddies 20 feet away, no problem, we can do that. You want to know what the blast waveform looks like behind you? We can do that. What about a waveform 10 feet above your head? We can do that too. All right. But wait, there's more. That's right. But wait, there's more. Notice I said waveform. Yeah, that's right. PEW-SOFT HD isn't just telling you what the blast pressure is at a point. No. It's actually giving you a full blast waveform at a microsecond resolution as if you measured it there. It uses wave propagation physics. Yeah, the whole time history of them. So guess what you can do at any point in space? You can compute the suppression rating. That's right. Remember, you what do you need to compute the suppression rating? You need the full waveforms to do that. So PEW-SOFT HD gives us those. See, you can't just, you see what now you're getting into how crazy I know this is. My wife literally called me a mad scientist yesterday. I actually, like, at first I was a little hurt, and then I was like, I'll own that. So you might be wondering, okay, I know that's a lot to take in that I just said. So you might be wondering, well, gosh, how do reflections come into all of this? Glad you asked, sir or ma'am. The code allows you to place reflecting surfaces at arbitrary locations currently defined by X or Y or Z planes. Okay, stick with me. So if you want to add a roof over the shooter, we can do that. If you want to add a hallway, you can do that. What about a berm at your shooting range? We can do that. What about creating a model of your bedroom? We can do that too. That's right. What if you're a SWAT team and you're the lead guy shooting in a hallway? Yeah, what happens to the guys behind you? Yeah, see what I'm saying? It's cool, right? And you can use bolt actions. You can use semi-autos. And also, your old friend, the omega metric, comes into play. That's right. We know how fast the gas is leaving the silencer, remember? That whole pesky old omega metric based on real test data in physics. Yeah, that tells us a lot of information about the forward pressure field coming out of the silencer. It's true. Now I need to let you know something important. And by the way, again, this is all in the article. In the article, it talks about what the tool is, what it can do, what the tool is not, what it can't do. So please read it if you're interested in actually learning about this. You don't have to. You can just look at pictures, which is fine too. But I need to tell you right up front, and it's in the article. I need to tell you right up front, it's important. This is not a CFD code. Okay, guys? This is faster, but also the difference between what a CFD code is and what PEW-SOFT HD is, like CFD, it solves the governing equations for mass, momentum, and energy at every point in the computational domain, and they're using an energy term that's analytical. Their input are assumed, okay? And it can be great. I mean, CFD is used in my job all the time. It's a valuable tool. Okay, but PEW-SOFT HD is different. Remember, in our case, we actually started with reality. We started with real test data. So how do we do this? Well, we back calculate source terms and we use wave propagation physics to propagate them to the domain. That's right. The source terms are anchored by the free field test data. They're real. They're real. Real as a heart attack, real. Real as a heart attack, real. To the point, our data is the realest. It's the realest that it gets. Is the real a microsecond resolution free field blast overpressure data collected with exacting standards. It is the best blast overpressure data that you can get. I know that because I can't get any better than that. You understand me? Okay, so you see where we're going with this. So back to my statement about all models being wrong. That's true. Never going to change. Always going to be true. But the cool thing here is that the existing muzzle and near suppression ratings in the free field that you've seen for 6 years, well, they're based on the real dang data, dude. Real as a heart attack data. And so that means on these maps, if you want to talk about uncertainty, well, dude, when you're near those points, that uncertainty is pretty low. So while these are engineering level estimates, which obviously all models are, these are engineering level estimates. Well, not all models are engineering level estimates. All models are estimates, but these are engineering level estimates. They're the best estimates we currently have for the time being, okay? And that is about approximately, give or take, 10,000 miles further than we were yesterday. Which is really cool, right? So for you physicists out there, just so you know, this code does not model high amplitude blast wave reflections, like from a high explosive going off in a room. If you need help with that, that's okay. Call us, and we are going to help you with your problem, but we're going to use different tools. We're not going to use PEW-SOFT HD for that, okay? It's okay. This one is for suppressed small arms. Okay, very good. So I know this might be overwhelming, and maybe the article will be more calm for you. It could be. You might need coffee if it's in the morning. This is a little crazy. I told you, Section 8. Anything you read in Section 8 is going to be ridiculously crazy, which is the point. It's so fun. So what we're going to do, we're going to talk about real case studies now to give you a flavor of how this works. Okay, Surefire, RC2, RC3, and the Huxworks Flow 556K at a time of 40 minutes. And dang it, time of 41 minutes and 4 seconds. I keep missing the post. That's like radio DJ 101, right? Oh, man. Mark 18 case study. This is going to be 8.1.1.4 in the report. This is Surefire SOCOM 556 RC2 versus RC3 versus Huxworks Flow 556K, all in hazard map space. And I realize that many of you may have skipped to this topic on the podcast without listening to the first part, which is totally fine. And honestly, it's expected. I don't blame you. Like a lot of other technical reports we publish, most of the information you really need as an end user are in the pictures, which is fine. You don't have to read it. It's fine, dude. It's free. The point of this report and this podcast episode is to document this for the record and explain it to people who care. Now, let's talk case studies, which is important. First one is in the free field. To prove to you that this makes logical sense. There's a method to the madness. Okay, so you can follow along 8.1.1.4. This is an intro talk, probably. Maybe it's the whole thing. I don't know. We're going to do the deep dive maybe next week after the Otter Creek Labs Infinity deep dive AK thing. I don't know. For now, let's keep going and see how far we get. All right, picture this. 556 Mark 18, 3 silencers. Surefire 556 RC2, 556 RC3, Huxworks Flow 556K. You may remember these silencers from reports 652 and 6151 and 682. Don't feel bad if you don't remember. There's hundreds of reports. Don't worry. We have a rankings table to help you find them. And there's links in this report. So you know the RC2, RC3, and Huxworks Flow 556K, yes? Cool. Awesome. What did we do for this case study? We used PEW-SOFT HD to create hazard maps for all 3 of them in the free field to show you the performance visually in 3D space from the 3 tests. Well, this is actually this is the top-down view of the 3D space from 3 tests, okay? These are literally the existing 3 tests that have been on the website for years, but modeled by our code with the real test data as model input. Okay, cool. The computational domain for this first case study, and we're going to do the next case study in a second, so bear with me. The computational domain for this example, we made it 3 meters by 3 meters. I know. So a little bit over, it's like 10 foot by 10 foot. Why do we use meters? I know it's going to frustrate some of you. The reason is because we show pressure in pascals in the rest of the report and the rest of the standard. And muzzle pressure sensor is 1 meter away. And, also because like this is like a cultural thing, acoustics people, like those guys that are like, look at sound but not blast. Like, remember, we are not acoustics people. We're blast people. The acoustics people really like decibels, which is a logarithmic Pascal. So yeah, we stuck with Pascals. If we had our way, dude, honestly, I'd used feet and inches and PSI or PSF. That's what I would do with America. But yeah, you got to play in their world. You got to, when in Rome. Anyway, this case study is free field. So just the ground in the model, yeah. Reflection case study, again, we're going to talk about next. Now, I want you to scroll down. You don't have to read all this stuff. It's pretty awesome if you want to, though, because it's like really technical and awesome in the report if you're a nerd. But what you can do is check out the first graphic in Figure 3. Okay, and guys, literally, the graphic in Figure 3 is the exact same graphic that is in Figure 1 at the top of the report. I just wanted to show it to you up front so you keep your attention. Okay, so Figure 3, and you can click to make it bigger, which is going to be important for you probably. You see the 2 white box labels in the figure? That's the suppression rating at the muzzle and ear. Cool, right? Those numbers should look familiar to you. Because they're literally what we showed you when we published the Surefire RC2 report in whatever year that was. And they were calculated from our test data. Yeah, we don't throw our data away. We keep it. It's real. Our test data was used to generate the simulation. Okay, so of course they are the same as they were, right? Of course they were the same. Why wouldn't they be? If the suppression ratings of the muzzle and ear in this simulation result was different than what we had presented to you, that would mean our code was broken. It is in fact working so far, which is good because this is really hard to do. Like this is not easy. Like I don't care. Like, you know what? That's not. Let me be clear. I know, because I work with these guys. I know there are people that for them it's not as hard. For like us at PEW-Science, we're kind of a small company. Oh, kind of. We're a really small company. For us, it's hard. This is hard. This is challenging. So I'm proud of it because, like, I know there's people who could definitely do this, but they won't because they're not into guns. It's a shame, really. Man, I'm telling you, some of the guys I know and work with, if I could just get them into guns, the stuff they could do. We'd have a bunch of Tony Starks running around. I'm telling you, man. You know who I really like? The Palmer Lucky dude at Endural. He followed me on Twitter. I want to meet that guy. That guy's awesome. Sorry, where was I? Sorry, I'm really tired. Right. The suppression ratings, muzzle and ear in the chart in Figure 3, they're what you've seen. You shouldn't be surprised about that. This is a top-down view, if that wasn't clear. Remember, the little man in the figure? There's a man. See the silhouette guy? He's the shooter. He has the gun. You see, he has a little arm there. His head's resting on the stock, and he has a silencer. And that's to scale, by the way, the silencer and the gun there, and the head and everything. It's to scale. He's shooting in the position from the test, and that's the mil standard position. And his silencer is 1.6 meters above the ground, and the map you see is, you guessed it, 1.6 meters above the ground. There are a lot of things in that picture. And I'm going to go through them real quick so you know what you're looking at, because you got to. I just gave you a map. You need to know how to read it, right? Let's do that. The title should look familiar. It tells you everything about the test, just like the figures in the hundreds of reports you've seen in Section 6, right? It has the silencer, the mount, the weapon system configuration. Remember, all that's important. Oh, you know what I didn't put in there is the stock position, but you know what? I'm going to show you how you're going to figure that out in a second. So, also it says up there, that's a PEW-SOFT HD hazard map. That's what it is. On the horizontal axis, we'll call that the X-axis for this purpose, because that's the designation we're using. That's our nomenclature for this tool. That's in meters. And then the same with the vertical axis. We're going to call that the Y-axis with our convention. That is in meters. And then the Z-axis is out of the page and into the page. Okay? The coordinates you see on the X and Y axis, or X and Y axes, the coordinates are relative to the end of the silencer. So 0, 0, 0 in XYZ coordinate space is the end of the silencer. Always, 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 always. Got it? Okay, always remember that. The picture is a 2D plane, so you can't see Z because you're a 3D creature, and that's a 2D creature. You can't see Z, but I can assure you the plane is 0. Z equals 0 is the plane. Where's the ground, you may ask? Where the heck is the ground? Well, that's at Z equals negative 1.6 into the page. Why? It's because the ground is 1.6 meters below the end of the silencer, remember? Mm-hmm. Yeah. Easy peasy lemon squeezy, really. Just like the test. You're going to be a computational blast engineer and physicist and researcher before you know it. Just stick with us. The computational grid resolution in this particular simulation is 3 inches. That's also labeled on the plot. That's labeled on the plot. We label that so you know the accuracy of the map. With regard to precision, we'll typically give you the suppression rating computational values to the nearest tenth for most things. I should say, this is important for you to know. These suppression rating maps are not interpolated. I think that's very important to tell you, because I don't know how serious you're realizing this is, but we can interpolate the grid. But what I want to tell you for completeness and to illustrate the gravity of this to you, what you're looking at is actually true 3-inch grid plots, generated by the code. Those are all data points. This is not a notional cartoon, as an analyst would say. This is a real simulation run. At every 3 inches in the space, there is a full blast load history, and then a computational run to compute the suppression rating. Okay. Faking this, I know, because I know there's going to be people who say that, faking this plot, it would be so hard. And I can tell you, and I can actually, I'll tell you right now, I can tell you from my experience writing the code to generate that dang guy shooting the gun, that black silhouette. Dude, I think faking this would be way harder than doing it for real. Dude, you know how much I hate drawing people? It is so hard. I have never been good at drawing people. And so I made the computer do it. I was like, I cannot draw this stuff. This is so hard. I'm just not artistic in that way. Never have been. There was a class when I was a kid called Commander Mark, and he taught you how to draw in 3D. I can draw straight lines real well and some curves in a certain way, but when it comes to living creatures, man, you tell me to draw a person or a dog or a bunny or something, boy, looks like some autistic kid special, man. It just what is that? Don't let him draw anymore. Anyway, I made the computer draw the man. At least it's consistent. Don't make fun of my weird stick man too. But you know what? We should call him something. He doesn't have a name yet, actually. So we got to think of a name, and we're going to do a poll, I think. Oh, you know what you should do? We should do a contest where the winner gets something cool. Maybe a PEW-SOFT sticker pack, which are very rare. What else? Oh, right. The Z scale in the plot that is inside the page and out of the page. The actual contours. In this case study that we're showing you the suppression rating. But that's not all we could show you. We could show you other stuff. We can show you blast overpressure. We can show you blast impulse. And we can actually show you any type of parameter that's a characteristic of the blast waves. Because remember, every 3 inches, there's a blast history that looks like the waveforms you see in the reports. It's just that they're propagating through the field, so they're different shapes and characteristics, and that's why there's a different suppression rating for each of them, right? So what is the code doing? Our code it's doing this for all 5 shots, and then we're computing the suppression rating on every single point in the domain for each of the 5 shots, and then the average is what you see in the plots, just like the test reports. But the test reports, although they are giving you the average suppression rating, they're only giving you at the muzzle and the ear, and then there's a composite. These hazard maps give you infinite points in space in the 5-shot average. Theoretically, yeah, your imagination is the only limitation. Well, and computer power and physical power to run the computers, and my patience. So yeah, so 0 to 100 scale suppression rating. We used true red and true green. Seemed like a good idea for this one. I think it looks clean. Let me know what you think about that. Contour lines are every 10, which also makes sense. So red is bad, green is good, red is danger, green is safe. When someone asks me, what's hearing safe? I say 100 on the suppression rating scale. But I thought 140 dB was hearing safe. Well, you're wrong. So if you're colorblind and you can't see these colors, I'm sorry, use the numbers that are labeled. Keep in mind that the suppression rating is not blast overpressure. Okay, I don't know how many times I can say that. But the lower the suppression rating is, the more intense the blast load is likely to be at that location to a human ear. And the higher it is, the less intense the blast load is at that location to a human ear. And so as a result, as you can tell, the shape of these contours look awful lot like blast loads coming out of a suppressed rifle, right? If you've ever modeled blast loads or been around those who do, you would recognize these as looking like blast load contour plots. Did you know you can see the ejection port blast there too? Yeah, coming out of there. So you can see it happen. It's all visual now. Oh, something else on the plot you need to know about. Jet stability index is in each plot. The lower that number, the faster the jet comes out of the silencer, the faster it breaks up and spreads out, the worse it is for the folks right by the end cap. The higher the number, the more focused the jet, the less intense the forward feel is, yada, yada. Oh, what else? Oh, technical report number and the rankings record number in the plots. Oh, that's what I was saying earlier. How would you know the stock position? Well, if you click on figure 3 and Surefire comes up here and you look at it and you see technical test report reference, silencer sound standard 0.6.52, when you or rankings record number, silencer sound standard 0.7.1.51, the 51st record in the data record in the rankings and the 52nd article in section 6, if you go to that report, you'll see that on the Mark 18 testing, it's stock position 4 of 6. So you can build this whole rifle and do it yourself. Prove this to you if you want. Okay, so it gives you that. It gives you the references. If you ever get lost and you wonder why a hazard map looks like it does and you need to understand more about the silencer behavior, then go to the mother report and read. And if you can't figure it out, call us or email us. Now, current version of the code is also in the plot. What are we on? We are on the PEW-SOFT HD engine is on 2.2.1 alpha. So that's more for us than it is for you, but trust me, it needs to be there because we need to keep track of stuff. It's important. This is going to get real big in a hurry, and we're going to lose track of stuff if we're not using numbers. So let's keep doing that. Just like section 6, I think it's going to get big. So we need to buy more computers probably. Oh, also there's a big watermark. Oh yeah, and the reason for that is one, it's our IP. Please don't steal from us. Okay, we're a small business, so don't do that. Also, remember, if something is not on our website, it's not from us, so it's not real. So don't trust anything not on our website ever. If someone's saying that Pew Science is doing something and it's not on our website, be very skeptical. And I'm going to tell you right now, in the silencer industry, people lie on purpose, and a lot actually. They lie a lot. And I don't know why it is that they are, but they're doing that, dude. And so we keep receipts of all that. And so part of that is our watermarks. Okay, cool. Thank you. Also now, okay, so now you know how to read the plots. So now we're gonna compare the 3 silencers together. This is what you came for. Sorry, I had to tell you how it all worked for first. Okay, this is super fast and super easy with the hazard map graphics. We're almost done. Figure 3, RC2. Hybrid design. Primitive hybrid, though. Ejection port blast, kind of high. Not like a Polonium or an M4 high, but high. Jet stability index, moderate. Which means what? Focused jet. The whole pressure field and hazard field is reasonable. Not the quietest environment with the Mark 18 being shot, but you could do a whole lot worse than RC2. Boy, you could do a whole lot worse than RC2. Powerful RC2. Classic. I love the RC2. Cool silencer. I always have liked it. Next up, figure 4. RC3 flows faster. Hybrid design like the RC2 actually. But the whole annulus dumps to atmosphere. Bro, remember that? That was a wake-up call. People didn't like that, did they? Why? Well, it's a lot of dump real fast. What happened? Stability index dropped. Broader jet. More severe. Was there less ejection port blast? There was. The muzzle blast, was it making up for that? Kind of still hurt you, right? Yeah, shooter's ear rating was similar to the RC2, like you saw in the test report way back when. Yeah, so it's still, well, we got 22.2 at the RC2, 22.4 at the RC3. Yeah. Just like pretty sure that's right. I'm pretty sure that's right. I have to go to the thing here. Oh, I don't know. I have to check. I have to double check that number before we publish that, but I'm pretty sure that's right. Yeah, it looks right because it's right on the contour there. So yeah, so 22.4. It's the same as RC2, but so you lost flow, you gained flow rate, but the blast pressure in the forward field came and hurt you again. So far, these maps should be tracking with, I don't know, everyone knows to be true with these silencers. I mean, you've shot these for how many years? You should know how they work. I mean, that's what these show, which is cool because it kind of gives you a gut check. We don't know the certainty of every single number on the plot, right? But we know general trends. And it's as good as we have right now. So far, it's jiving pretty good, I think, which is cool because the whole point of this is to be useful, right? Okay, it's tracking with what we feel is reasonable, which is always good for a model. Now let's go to the next one. Huxworks Flow 556K. Oh man, super fast flow rate, true flow through design. Yeah, people always ask when a new silencer comes out, is it flow through? Well, if it's not Huxworks, it's not flow through. That's an easy question to answer. The Flow 556K is a flow-through silencer, flow-through 556 silencer, and it's really short. Some people call it a pipe bomb. That's fair, probably, but it's not a pipe bomb. And look at the map to see why. What it actually is a blast forwarding device that actually works, just not well everywhere. Stability index drops like a rock. Jet propagates like a huge boom. Ejection port blast is minimal. In the free field, the shooter is safer than with the Surefire solutions. Yes, that's true. Kind of. On a standard untuned gun, tune your gun, you might, the other sound fields might look different than, right? Okay, but it's not going to sound good to you, is it? It's not going to sound as good as the RC2, is it? Like if you're like far away from it, right? Right. Now let's move to the lightning round. We're going to talk about the next case study. We're going to put the shooter in a more dangerous environment with the same gun and two of the same silencers. Okay, we're going to do that at a time of 1 hour, 2 minutes, and 20 seconds. Okay, oh man, we're almost running out of time. Oh, we can do it. I know we can. 1 second. Okay, reflections, moving outside of the free field. Okay, that's section 8.1.1.5 in the report. Now, what did we do? We changed the computational domain. We took our 10-foot square and we put a wall next to the shooter. What type of wall did we put, Jay? Well, glad you asked. We put a brick wall. It represents like just a sample. It doesn't matter. It's a sample side of a building. The shooter is outside next to a building, okay? Are you ever going to, well, it does matter, but are you ever going to shoot next to a wall? I mean, you might. I don't know. Everything is literally the same in these simulations in figure 6 and 7, except for the wall in the domain. So the domain is the same. The atmosphere is the same. The grid dimensions are the same. The computational resolution is the same. You just have a wall. But the calculation is now more advanced in PEW-SOFT HD. We have to tell the code how long to run. Code will run forever if you let it. The robots are persistent, dude. PEW-SOFT HD is very obedient so far. It's not self-aware, which is really good. You don't want that. So you get ants in the domain. You have to tell the code how many times to consider blast load traveling from the gun to the ground, and to the wall, and to the ground, and to the wall, and to the ground, and to the wall, all that stuff. Every time there's a reflection, some of that is coming back to the shooter and every other point in space. I'm sparing the details right now. You can read in the report, but in this particular simulation, because there are only two surfaces and we are outside, or at least our little man is outside there, strapped in simulation hell, it looks like. We only need a fifth order calculation in accordance with our sensitivity runs for this one. I say only, but because PEW-SOFT HD can run nth order calcs. So that means it can bounce reflections forever and keep adding blast severity if you let it. Because what you're doing is you're also telling the code how much decay there is off of the surfaces and how many bounces and all that good stuff, right? That's how to make this work. So in this fifth order analysis, what do you see the RC2 do in figure 6? Like, do things get louder for you? Like for everyone like nearby? Yeah. What about the suppression rate in the shooter's ear? What happens there? It dropped by 10 points, dude. Uh-oh, SpaghettiOs. I've been telling you this every week for 5 years. This is going to happen. The computer overlords agree with me. You see? Then look at flow 556K in figure 7. Look at that. What in tarnation? What do you see there? I'll tell you what you see. Chaos brought about by extreme distal flow rate. What we have here is a hazard field that's very, very, very dangerous over 2 meters away from that wall, away from the shooter. Could that be an issue for your team? Could be. Depends on how many walls there are, right? Yeah. Check out what happens behind the shooter and back to his right. Remember when the flow made it safer than the RC2 back there in the free field? But what about now? Like if you go and scroll up and look at figure 5 and then figure 4, and then now you look at figure 7 and figure 6, what happened? Looks like the RC2 is now safer back there and to the right of the shooter. The relationship has flipped in the pressure field, all because of that dang wall. That's the only thing we changed, was that wall. Isn't that crazy? So again, you got to ask yourself, what if you had a roof? What if you had a hallway? And since we've run some cases already, I can tell you it gets ugly. It gets ugly quick. And I think it's important for you to know that. And I think this case study is going to help people understand why Huxworks flow through silencers, especially the 556K. It might hurt you in certain situations compared to other silencers. Distal flow rate matters. I think the omega metric is shown to be real. Obviously, it's real. It's calculated from real test data, so it is real. The PEW-Science data is real. Our analysis is real. And I think these simulations are a new tool to help you get the most out of all this that you can. And I hope that helps you. Okay? That's what these simulations are for. That's all they are. They're just things to help you and help others. Okay, so we're going to wrap all this up at a time of 1 hour, 7 minutes, and 24 seconds. We're going to wrap it up. Good time. That is conclusions and acknowledgements. And by the way, this is also in the report written down. Everything I've told you today is written down, mostly. I'm going to tell you guys, this took a very long time, and I'm so happy to give it to you. And, this is just, I've just done this such a long time. Blast loads are real, man. It's what I do. Blast loads are real. Blast overpressure is real. It can hurt your ears. It can hurt your brain. We want you to be safe, man. Please use this information to make yourself safer. Make your loved ones safer. Make your buddies safer. Let us know which tests you're interested in seeing mapped in section 8.1. It's super fun. Honestly, I love this, dude. I was going to say I love this more than testing, but I like them both equal. My whole career, I've always thought maybe I'll stick in analysis, maybe I'll stick in testing. I'll go back and forth, and eventually I just ended up doing both my whole dang time. I've just been doing both my whole time. I'm one of those guys, and I'm sick for it. The really cool thing is imaginations could really run wild here. I already have some ideas. We're excited to see what you and us are going to come up with to run. And it's going to be so fun shopping for computer hardware. I haven't done that in such a long time. Our ThinkPads here at PEW-Science are screaming right now. I need some more horsepower. The suppression rating is really cool, right? This is so cool. There's infinite possibilities. Gun range by your house that you love. What system is going to do better there because of that dang awning? I don't know. I think we can help you figure that out. It's not perfect, but it's more advanced than we were yesterday, right? So that's what I think. I think this is going to help everyone. Now, finally, I would like to thank some people on the list here, and they're listed here, and the categories are listed here in the report at the end. The first is my family, and specifically my wife. I don't know if you guys know this. I don't talk about my personal life a lot. But she's the one who pushed me to make Pew Science. After I had the idea for a decade, she pushed me to follow through with my idea to found the company. So it's awesome. She's put up with me all these years, and even as I wrote this code, boy, yeah, she's a good woman, man. I love her so much. Yeah, my kids, they're gonna oh, they don't even know what's in store for them. Also, Pew Science staff, boy, do they put up with a lot. If you only knew. Oh, well, it is what it is. Also, you Pew Science members and all of you listening, man, you know we couldn't do this without you. Like, it's impossible to do things like this without your support. You know, we funded this all with your contributions, dude. This was created with internal Pew Science funding, and we can't do that without you guys. You know, imagine doing this for like over half a decade with like a bunch of people that selling the silencers. They just want you gone, and they're fighting tooth and nail to ruin your reputation and say bad stuff about you and lie and do all this stuff. It gets so crazy. And this whole time, when all that keeps happening and will keep happening, honestly, there's been people sticking by us, being like, you know what? I think we believe in what they're doing. So that's cool, man. It makes you feel good when people are like supporting your hard work. You know what I mean? Because it's real hard. So thanks, man. Like all you guys and women, man and girl, man and women. Thank you. It really means a lot. So your support's cool. Also, our laboratory clients, boy, you know, not every client that we've had, we're not the favorite person of a lot of our clients, because, you know, they come and they give them answers they don't like and all that good stuff. I'm sorry. But hey, you know, we love all of you, and we are very thankful for all of you and your trust, which is huge. We value that, and we hope we can still help you. We hope we can keep helping you. Okay. We welcome your feedback. Always have. And finally, oh, and I'll say before I go on with clients, you know, you guys, you Pew Science clients show the world that innovation and competition is possible. So let's keep that going. I think that's cool. But okay, so finally, last thing I'll say, the last person or people, a group of people I'm going to thank, OPSEC and everything. I'm not mentioning names, but all the folks that taught me personally how to do all this over the past 25 years now, since my higher engineering education, I guess, like through all those years and late nights in the lab, working for professors in undergrad, trying to figure things out, to busting everything, you know, just cut my teeth on it all, getting to grad school, doing that, figuring out, learning, getting inspired, working at crazy places, doing crazy stuff all over the world, being taught how to do things and why it matters, how you save lives doing it. Blast, get emotional. Blast is what I do. Couldn't do it without you, man. All you guys. Yeah. Cheers to many more years of new discoveries. I tell you what, many more. Boy, did you ever think? Yeah. Did you ever think we'd get this far with testing silencers? Oh, man. Yeah, let me know how you like it, everybody. I tell you what, I think this is, I'm just so tickled. This is going to be so cool. What a neat next, what would you call this? A next chapter in the journey. We're still going to be testing, but look what we can do when we get the test data now. We can visualize it. A picture is worth 1,000 words, okay? I'll talk with you folks again soon. All right, bye.